Hello, everybody. Uh, Today, I'm very glad to have this opportunity to present my paper titled The Impact of Automation on China's Labor Market, Macro and Micro Level Evidence. I'm Guangsu Zhou from Renmin University of China, and this is an empirical paper co-authored with Lixing Li from Peking University and Ling Shengmeng from the Chinese University of Hong Kong. And I will present the paper as the following structure. At first, let's say some important facts about China's development of AI and automation. We all know that automation and artificial intelligence are important trends of development. And the development of automation and AI provides new opportunities for China. So the Chinese government issued new plans for AI development in 2017. With the fast development of automation and AI, it has very significant impacts on China's labor market, especially its substitution effect. Since intellectualization and AI integrate intelligence into the production process, the substitution effect of it becomes more and more significant. This conclusion is also supported by evidence from other countries. From the World Economic Forum 2016, we can find that over the next 5 years, advances in robotics and artificial intelligence technology will result in 7.1 million job losses in 15 major economies. And 57% of OECD's jobs will be replaced by automation in the next 20 years. So even though many papers have explored the impacts of automation on labor market, but the conclusion is inconsistent because the total effect depends on both substitution effect and the complementary effect of it. And also different industries might have heterogeneous impacts because different industries have different degree of skill economy, different knowledge and technology intensity. We know that automation and AI have larger impacts on jobs with routine tasks and lower human capital and lower income. And with the fast development of AI, the labor market is separated in two subgroups, the low-skilled, low-income group and the high-skilled, high-income group. And we know that lower-skilled labor force faces less job opportunities and relatively lower working income. As a result, the economic inequality becomes larger and leads to tense social relations. Let's make a brief summary of the literature. From the literature, we can find that they are mainly focused on developed countries' situation, but the research on developing countries is rare. So our paper wants to use China's data to explore the impact of automation on China's labor market. So the contribution of our paper is as follows. First, this paper provides more of automations in the labor market for developing countries, assess the impact of automation on China's labor market comprehensively, which means we explore the impact of it by different jobs, different regions, and by different labor force characteristics. Third, this paper estimates the effect of automation on employment, working hours, and working income, which can help to evaluate automation's impact on labor force economic welfare more objectively. Next, we will look at the data used in our paper. The original data comes from Free and Osborne, 2017. They estimate the probability of computerization for 702 detailed occupations according to the standard occupation classification. And the procedure and the calculation strategy for their paper is as follows. We have no time to introduce them in details. So we have the first task in our paper is to estimate the probability of computerization for occupations according to the classification of China based on the result of free and Osborne. So we have to use a lot of data source to merge the probability of free and Osborne to the classification of occupations in China. So this table shows the result of this merging process. And after merging, we find the probability for 64 occupations among the 79 occupations in Chinese census data. And the second, we have to describe automation's impact on China's labor market on macro level. Which means to calculate the probability of automation for different regions, industries, and the labor forces. We can calculate this probability of automation on macro level by using the census data of 2000, 2005, and 2010. For example, for the calculation on city level, we use each occupation's employment number as the weight matrix and calculate the weighted means for this probability of each city. And by using similar method, we can also calculate the probability of automation for each province, each city, industry, and different labor forces. Then, after we get this probability of automation, we can explore the relationship between this probability and the main outcome variables of labor market on city level. This empirical work is also use data from the census data of 2000, 2005, and 2010. The dependent variable of this model is the employment number on city level, the average working hours on city level. And the key independent variables in our model is the probability of automation on city level. And we use the first difference model to make this estimation. And the control variables used includes the logarithm of GDP per capita, the logarithm of population, the ratio of the secondary industry, and the ratio of tertiary industry, and etc. At last, we also use the China Family Panel studies of 2010 and 2012 to explore automation's impacts on individuals' employment status, working income, and working hours. The empirical model is similar to the one used on city level. And we also control variables on individual or household level to make the estimation more accurate. Then we will show the empirical result. First, we describe the effect of automation on labor market on macro level. The first dimension is by regions. From this figure, we can find that the less developed middle and western regions in China have higher probability of automation than east part of China. And the different regions have shown different patterns. Take the northeast regions of China as an example. It has lowest probability in 2000, but has higher probability in 2010. The reason might lie in its industry structure change and the production capacity. We also calculate the substitution probability by industries. And we found that industries such as farming, forestry, animal husbandry, and fishery has the highest probability of automation. The industry focus on non-routine jobs or high skills has lower probability of automation, such as education, health, social security, and the social welfare industry. And then we also calculate the probability of automation by different labor characteristics. The first is by gender, and we found that female is easier to be substituted by automation. The second dimension is by age group, and we found that the younger group has lower probability, but the elder group has higher probability of automation. And the gap between different age groups is becoming larger and larger. The third dimension is by education, and we found that the probability of automation is decreasing when education is increasing. And the last one is by income, and we found that the probability of automation is negatively correlated with income. And we found that the vulnerable groups on labor market has higher probability of automation. And this figure shows the correlation between the substitution probability of automation and the major outcome in labor markets, such as the employment number and working hours. The first two figures use data from 2000 and 2005, and we found that there is a negative relationship between the substitution probability and the employment number, and positive relationship between this probability and the working hours. And the data from 2005 and 10 shows a similar relationship between these variables. This page shows the empirical results estimated by the regressions. And we can find that for the effect of automation on city level employment by using data from 2000 to 2005, there is a significantly negative relationship between these two variables. And this negative effect is larger for female low education group and the old group. And this effect is also larger for those who live in cities but have rural hukou status, which means the rural to urban migrants in China. So the probability of automation decreases the growth of employment significantly from the result of this table. For the result of the effect of automation on city level average working hours, we found significantly positive relationship between these variables. And the probability of automation increases the growth of working hours. And this effect is also for female lower education group, older group, and those with rural hukou status. By using data from 2005 to 2010, the results are similar, and the conclusions are consistent with the previous result, but the effect becomes larger. So the result also similar to the result between the effect of automation on and the city level averaging working hours. Then we made this empirical analysis by using China Family Panel Studies data. This is individual level data. And the sample we used aged between 20 to 60 and with non-farm employment. And we also found that the probability of automation has negative impacts on the probability of employment and working income, but has positive impacts on working hours. The results are also larger for respondents who live in cities but with rural hukou status. We also use the robot usage as a variable to measure the probability of automation. And this table shows the result of this. And we found that the robot using decreases the growth of employment and increases the growth of working hours. This effect is also larger for female lower education group and older group. And this effect has becoming larger. At last, I will make a brief conclusion of the findings in our paper. Based on the data from Free and Osborne, we found that the probability of substitution in China is also very significant. And based on the estimation in our paper, we found that the effect of automation on labor market outcomes such as employment at city level, working hours, and income. And this impact is larger for female, low education group, older group, and those with rural focal status who are vulnerable groups in China's labor market. And this paper has provided more evidence of automation's substitution effect, which means more and more jobs might be replaced by machines and automation technologies. This effect implicates that more attention should be paid on the negative impacts of automation on labor market. On the one hand, we should try to increase human capital or skills of the substituted labor forces. On the other hand, we should try to minimize the welfare loss caused by the decreased wage growth or the extension of working hours. That's all about my presentation. Thanks for your listening.